Hi, and welcome to this presentation about how to architect for continuous delivery. This was a presentation that I have delivered for Roche in their DevOps conference, where I also got this nice jacket that you can see here with the logo of the conference on the back. This conference was on the 4th of September 2029 in Poznan in Poland. But firstly, quickly to myself, my name is Romano Ross and I am the Chief of DevOps and a partner at Zülke. I work for Zülke now since 22 years. I joined Zülke directly after university as a junior .NET engineer, became then an expert software engineer, then an architect, and finally a consultant. And one thing that was always at my heart is how can we continuously deliver value? How can we automate things? And how can we ensure the quality of what we are building? And how can we organize ourselves across the value stream? And when the whole DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup in Zurich. We have over 2,500 subscribers there. And I am also one of the organizers of the DevOps Days Zurich, which is a yearly two-day conference in Zurich. And these DevOps Days, they are all around the world, in all of the big cities. And I am the president of the DevOps Days Zurich. Now, you can see DevOps lies very close to my heart. This is also why I have my own YouTube channel with over 250 videos all around DevOps architecture, platform engineering. I also write my own book on the digital factory, and I also tweet and post a lot on my social media channels. So if you want to learn more, you can follow me on these channels. In the projects, I work in different industries for different companies doing DevOps transformation, platform engineering, architecture, and so on. At the moment, I'm working as a product manager for a platform we are building for different customers. Now, when I go to different companies, what I see quite often is this picture that you can see here. And together with an artist, I have come up with this picture. In the middle, you see the clients, you see the business with the where they're having big ideas, they have huge plans, and they are writing these plans into Jira tickets and Word documents. And then they throw it over the wall of confusion to the development team. The development team says, yeah, if you want to have that, we can implement that, and they implement something. And then they throw it over the wall of confusion to the testing team. The testing team looks at the Jira tickets or the Word documents. They look at what has been implemented. It's not the same. But they test something and then they throw it over the wall of confusion to the operation team. And the operation team says, how can we operate that? That will never work. But somehow, with a lot of night shifts, they get it to work and it goes back to the business or to the customer. And they are saying, what is that? We cannot use it. This is something that you see, of course, not in that extent, but of course, in all different colors and flavors. This is something you can see in many enterprises. Now, what you also can see in there is in blue, there is the value stream. And this value stream is completely broken by these walls of confusion. These walls of confusion, they are coming from the silo organization. Usually you have a business silo, you have a development silo, you have a testing silo, you have an operation silo. And of course, all of these silos, they have different goals. So there is no alignment. On top of that, you usually have legacy systems, legacy application landscape, legacy processes, and of course, security, quality assurance, all of that is something you do afterwards when it's already in production. Especially when you look at a Roche, you also have regulatory and compliance, which also do their part in such a value stream. Now, of course, there is a solution, and it is DevOps, because with DevOps, you have a mindset, a culture, and a set of technical practices which allows you to organize yourself across that value stream that you see in there, and go away from working in projects into the direction of products, where you are continuously delivering value and updating a product and deliver that product. Now, of course, we need to talk about the people. And as I said, DevOps is all about organizing across the value stream, which includes all of the people that are working on a value stream. Now, the term DevOps is not very wisely chosen because it says development and operation. Now, there are some smart people out there which say, oh, we need to fix that. Security is very, very important. Oh yeah. So we need to call it DevSecOps, development, security, and operation. And another bunch of people is saying, no. Business, they are giving us the money. Business is very important. We need to call it DevOps, which is business, development, and operation. And you can see this whole discussion goes nowhere. We should have sort of a term that is DevSec, Bits, Arc, Comp, QA, Ops. And I'm pretty sure I have forgotten someone. We can also call it DevXOps or DevStarOps, or we just call it DevOps, because DevOps is about bringing all the people, process, and technology together to continuously deliver value. This is what DevOps is at its heart. Now, one thing that I always point out when we are doing DevOps, as said, DevOps is not only about the development and the operation. It is also about the whole value stream. And the whole value stream starts when you are creating your idea. Until that idea is in production, that's the important thing. Which means we also need to take care about building the right thing. So what is the right thing? How do we identify the right thing? And then when we have identified the right thing, we need to build it right. And that's also a very important thing to think about, because building the right thing is all about effectiveness, and building the thing right is about efficiency of it. And what I usually say, we need to build the right thing right. That's what we want to achieve with DevOps. And of course, DevOps has been analyzed by science. There is this absolutely outstanding book, which I can heavily recommend to you to read, from Nicole Forsgren. You only need to read part 1 because that's the most important part. There they have scientifically analyzed why some companies are delivering faster and are better than companies which are not doing DevOps. And they identified 24 key capabilities that drive exactly this DevOps. And you can see them all here. They have categorized them into 5 key capabilities. You see there is the continuous delivery capability, the architecture capability, the product and process capability, the cultural capability, and the lean management and monitoring capability. These are these 5 capabilities, and they are very important to know because they drive how good you are when you are doing DevOps. Now, one very interesting thing about that book is that they have this picture here, which you can see here. And that's, in my opinion, one of the most important pictures in the whole book. Because what you see here is they did not go and identify only these 24 capabilities. They also analyzed how they interact with each other. So it means what is the dependency of this capability, or what does it influence? And in very simple words, you can say, when you want to achieve this thing on the right, you need to do what is sort of on the left side. And that's always important to understand for many decision makers. And usually it is quite logically that you want to achieve what is here on the right side, but you of course need to invest on the left side in order to achieve that on the right side. And this is sort of, for decision makers, like a map where you can go and say, okay, what do we have? What do we want to achieve? And then you can go into this direction. Now, what I usually also hear a lot is, how can we measure the software delivery performance? And also, of course, how can we optimize that? And again, you also see what influences the software delivery performance in there, and what you need to do in order to get a faster software delivery performance. But let's dive in and see how you can measure the software delivery performance. And here we have the DORA Metrics. These are quite famous, and let me tell you that these four metrics, they are the only scientifically proven KPIs how you can measure software delivery performance. Of course, all of the other metrics are also okay, but these are the scientifically proven ones. So let's start with the lead time for changes. This is the amount of time it takes from code commit, so when you have committed the code into the source code repository, until this change is in production. This is the lead time for a change, and you can see the lead can do that in less than an hour. In less than an hour, a code change goes into production. That's the lead level. The deployment frequency is the second one. This is how often a company or an organization can deploy into production. And here it is very important to understand, in DevOps we distinguish between deployment and release. A deployment is bringing continuously a new version of the compiled code into production. A release is switching on the feature toggle in production or in the code so that a feature is released. That's an important distinction, because with that you can continuously deploy into production without turning on the feature toggle. And here you can see the lead do that on demand, so multiple deployments per day into production. You also see these two, like the lead time for changes and the deployment frequency, they are all about speed. Now, the bottom two, they are about stability. So here we have the time to restore a service. It is also sometimes called mean time to restore a service, MTTR. And this is how long it takes to recover from a failure. So when you have a deployment and something fails, how long does it take to recover from that? And now you also see the distinction between speed and stability. When you deploy faster, it can be that, of course, some of these deployments can be wrong and therefore you also need to have stability to recover fast from these failures. And there the elite can do that within less than an hour. And then we have the change failure rate. This is how the percentage of how many deployments that we have done have introduced a failure in production, and the elite is at 0 to 15%. So these are the 4 DORA metrics which we have, where we can scientifically proven measure the software delivery performance. And one thing that I always need to say here is you don't need to be elite. There is absolutely no reason for that. What you need to do is to start thinking about your context. What is important in your context? And then come up with the right measurements according to these 4 measurements for your context. And it can even be that in one application you have different KPIs or different DORA metrics than in the other one. So just to say that. Of course, when you then look at the benefits, and the science has not stopped with this book, they are even now creating every year that State of DevOps report where they are comparing companies which are not doing DevOps versus companies which are doing DevOps. And you can see that companies which are doing DevOps have a massively increased deployment frequency. They have a massively increased lead time for changes, also restored the faster time to restore a service, and also a low change failure rate. When you sum that all up, you can clearly see that you have a faster time to market, more value for money, a higher quality, a higher customer satisfaction, and top qualified employees. And this again is exactly what the CIO of today's enterprises wants to have. And this is also why many companies want to do DevOps. Now, doing DevOps requires some practices. And I want to show you some of these practices which are, in my opinion, very important. And one of the first ones is the so-called value stream mapping. Now, many people are coming to me, or customers are coming to me and saying, hey, we need to improve our CI/CD pipeline or our software development. And of course, you can go, or I can go in there and fix that and make that a little bit faster. And of course, in the past, I have also done that. But what usually then happens is you get sort of other problems down sort of the value stream. And that's an important thing to understand. And that's why I always say you need to apply whole system thinking. You always need to sort of think in the whole system. And in order to be able to think in the whole system, you need to do value stream mapping. And this is an absolutely simple technique. All you need to do is, when you have a product, you need to bring all of the people working on that product, because they are a value stream, into a room. You need to give them Post-its and you need to tell them, okay, what are the steps that we need to have to bring an idea into production? And you get feature definition, design, code, test, and so on. When you have done that, you say, okay, now who is responsible for that step, or who is doing that step? So product owner, architect, developer, tester. Good. Now you already see quite a lot of handoffs. This might be a problem, but we continue. We then say, okay, now we want to measure the efficiency of each one of these steps. And we go with PT, the process time, LT, the lead time, and the percentage C&A, the percentage complete and accurate. PT is the process time. So how much value-adding work are we doing in there? No, not how much. What is the time of the value-adding work in there? So, for example, when we look at feature definition, then the PT is 4 hours, which means the product owner sits down and does 4 hours of really value-adding work where the feature is defined. The lead time is then the time from the start until the very end of that process step where the other process step can start, and this is 48 hours. So you then also see how many waiting time is sort of in that step. And the percentage complete and accurate, this is a number where we see the quality output of that step, here 80%, which means in 20% of the time we need to go back to that step because we have a question for the product owner about this feature definition. So when we have done that for all of that, then suddenly we see where the bottlenecks are. We see, for example, there in code, we have a percentage complete and accuracy of 60%, and in test, even a bigger one, 50%. We also in test, we see process time 8 hours, lead time 336 hours. This is a huge waiting time. And then we can start optimizing that value stream, because now we see the whole value stream. We can also measure the efficiency, we identify the bottlenecks, and of course, when we start to optimize, we might see some changes in that value stream while the optimization is progressing through this value stream. Product development is really all about modern software development across that value stream, where you can see this infinity symbol, where you need agile backlog management. In code, you are doing agile software engineering with version control, build continuous integration, and test automation in test. You need to have a staging environment for the deployment. You want to do canary releases with your feature talkers, so you want to distinguish between the deployment and release. You want to proactively detect issues. For that, you need to have a full stack telemetry. Now, when we look at built-in quality, this is also one of the very important cornerstones of doing DevOps. Now, again, here I have drawn a picture or a comic together with the artist, and what I usually see is this picture here that you can see here, where you have the developers that are getting bugs from the testers. They are saying, oh no, it's not my fault, please go to the product owner, he wished for that feature, he wanted to have that exactly in that way, and so these bugs are just going around there, and suddenly they are with the customer. So where you want to go in the future is to go into a collaborative approach. And here again, it's very important. You want to start also focusing right from the beginning on build the right thing. And then with testing and automation, you want to build the right thing right. That's the important thing. And here is just a quote from an agile coach, an ex-Tesla employee, Joe Justice, which worked at different of the Musk companies. And he says 50% of the money a Musk company invests in a new product is in automated testing. And that is a huge number. Think about your product or your project. Usually this is way below 10%. 50% that you are investing into testing. And when you now look at the mask companies which are investing 50% of their money into automated testing, then this should on that you should have a thought on. So what can we do, or what is sort of the industry doing? When you look at the traditional model, how we tested, we usually use that V model that you can see here, where a business analyst first writes a feature in Java, and then another business analyst derives out of that feature a user story, and then a developer comes and he or she writes code. And if we are very, very, very lucky, then he or she will write also some tests. Usually we are not so lucky. Then a tester comes and tests the story. And then another tester comes some time later and tests the feature. And this is all about delayed feedback. Usually it can easily take 3 to 6 months from writing the feature until you are going to test the feature. Where you want to go is you want to shift left, which means you need to write the feature in a form which is testable. And for that, we are using behavior-driven development. We write the acceptance criteria of the feature in the given when-then form. Also, the user story will be written in that form, and then the tester can directly extract this given when-then form into the code, generate tests out of it, and with that he or she can do test-driven development, where we are first creating tests before we are writing the code, which means we are shifting left. The whole testing, testing the story and testing the feature is automatically done by automated tests. And this is how agile testing works, and this is how we shift left. Now, this also has a huge impact on the testing pyramid. Usually the testing pyramid in many companies look like this, and they are also very focused on finding all of the bugs. And this is why it looks like that. You only have a few unit tests, you have some integration tests, and you have a huge number of end-to-end tests, which are very, very slow, very expensive, and take quite a lot of time. The other side, the agile testing pyramid side, is about focusing on preventing bugs. So you go into a risk-based approach. You analyze your system and you identify the risky parts, and of course you will test them very, very good, and the not so risky parts. And when you are doing test-driven development and behavior-driven development, you will end up with quite a lot of unit tests, integration tests, system tests, some integration tests, and only a few end-to-end tests, which of course are still slow and expensive, but the cheap and fast ones, the unit tests, are clearly much, much more. This brings us to this continuous quality assurance, where you are shifting left, and there you can clearly see already in the planning we are building the right thing, which is we are going into having behavior-driven development, where we are creating the acceptance criteria in a form where we already have them ready for testing. Definition of ready is very important. In code, you want to apply test-driven development, clean code, pair work. In build, you want to have all of the test automation, automatically checks like static code analysis. In test, you want to have a very good definition of done with automated end-to-end tests. Then, of course, when you are deploying, you want to do production testing, so a subset of the tests get executed in production. In release, you want to have ownership for quality in the team, in the DevOps team, across the value stream, not that tester is now responsible, or that operation person is responsible. And again, you want to find your bugs before your clients do with proactive detection, and for that you need to have a good monitoring. Now, another very important topic nowadays is security. And with all of these cybersecurity vulnerabilities that you usually have, you want to also shift left the security. And when you look at your continuous delivery pipeline, then this does not start or end with continuous integration and continuous delivery. It starts already with the continuous exploration, building the right thing already, and it ends with a release on demand. And this is just an example of a continuous delivery pipeline. And of course, out there are vendors which say you, hey, we can cover you, we can cover everything. Usually, when you have a closer look at that, you need to replace some of the parts of it. But of course, they are very, very good tools. But in the end, you will always have some specialized tools for finding vulnerabilities. And in there, what you always want to do is when you are committing your code, you want to have merge requests. You want to do static code analysis with software composition analysis, license scanning with static application security testing, container scanning, and secret detection. Then when you are deploying, you want to do a dust with dynamic application security testing. And one very important part is also, even when you are in production and you're not doing any changes, you need to have a scheduled pipeline which regularly checks if everything is still okay, because new vulnerabilities will be found during the time no change happens in your code. So you need to have a scheduled pipeline. Which brings us to continuous security. When you are planning, you need to do threat analysis. When you are coding, again, merge requests, and then you want to have these automated tests that I just showed you directly into production. In production, you want to do penetration testing. Again, you want to have proactive detection, and you need to have a good monitoring for security. Now, what I always say is, when you are building a system, you need to architect for operability, and you always need to have that in mind. And also, as a developer, you need to build your stuff so that it can be operated here. So you always need to have that in mind. And in that case, monitoring is very important thing, and it goes right into the direction of observability. And just to give you quickly an overview about that, I have created this slide here. So in the past, we had these typical two-tier application where you had a user interface and a database, and sort of the database was the holy cow in that system, which means you had metrics with and some logs, and this was called monitoring. Now, after that, we had bigger application. We called them three-tier application, where you had a user interface and maybe also a mobile application, and you had that application server which exposed some of the APIs, and of course you had a database. So in there, when you have a user interface or a web application, and you have also a mobile application, you need to know where is that stuff coming from. So what you need is tracing, and there we have application monitoring, and of course, because we also have now an application server, we also introduced infrastructure monitoring. And of course, our application landscape grew bigger and bigger and more complicated. Nowadays we have distributed service-oriented application with microservices and all the like, where we have user interface, mobile application, and also third-party components and APIs that we are exposing. And there we cannot anymore only rely on application monitoring or infrastructure monitoring. We need to apply observability to this system. And this is an important thing to think about when you are building an application, when you're architecting and also coding the application. Which means also there we need to shift left. We need to architect for operability. When we are coding, we need to build in this application telemetry, which is really, really crucial. Infrastructure as code helps also here. And in my opinion, everything should be code and go into your Git repository. Then we want to have continuous integration, where you integrate everything together, of course also with automation. And when you are going to deploy something, you want to have a staging environment which is congruent to the production environment together with deployment automation. When you are going to release, you want to use feature toggles for canary releases and for dark launches. You want to have again cross-team collaboration, and you need to have monitoring or observability tools in place in order to monitor your application. Now, based on all of that, what I just told you, it is quite clear that this is quite overwhelming for many of the teams. And the cognitive load on many teams has risen to the point where many companies are now introducing platforms for them. And you can also see all of the big consulting companies like BCG, McKinsey, and also Gartner is clearly predicting that until 2027, 75% of the organizations will have created a platform around that, so to enable the teams to do DevOps. And when we now look at modern software development, and when we bring all of that, what we just learned together, you can clearly see that doing modern software development across that value stream is quite massive. You need to do quite a lot in order to continuously deliver value. And this is why many companies are going into this direction of having platform engineering. So what we have there is you have the platform team which builds a product, and this product is your internal platform. This internal platform consists out of the tools that are needed to build the products and the capabilities that are needed to build the products. So this platform is your internal product, and the customer of this product are the product teams. The product teams by themselves, they want to do DevOps. They build, run, and maintain their products. The platform team, they are building, maintaining, and running the platform. So the platform team enables the product teams to do DevOps. Now, let's have a look at a very interesting case. For example, the platform team provides monitoring or observability capability, as we have seen it. The product teams, they need to architect for operability. For that, they need the capability of observability or monitoring capabilities. So the product teams, they are using the capability provided by the platform team or by the platform to monitor their application. It is not the platform team that monitors the application. With that, the platform team generates value for the product team, and the product teams generate value for their customers. So in summary, what we have seen, which is very important, you need to build the right thing right. Don't focus just on pure automation or on quality. also think about building the right thing, because by focusing on building the right thing, you can also leverage quite a lot of things, and also the teams don't get overwhelmed by just implementing thousands of features. So building the right thing right is a very important technique in DevOps. You also have seen the 24 key capabilities and also that nice picture which shows you the relationship between these key capabilities. And also that is very important. Think about these 24 key capabilities and also about the dependencies of it when you are implementing DevOps in your company. Then another important step is the continuous testing and the building quality. Here, everything goes into the direction of shifting left this quality. So there you want to use behavior-driven development, building the right thing, and by applying test-driven development, you build the right thing right. That's how you do building quality. Continuous security, again, also very important. Here also shift left is important. You want to add automation to your pipeline, as we have seen it with the different security mechanism. And because all of that is quite overwhelming for a team alone, you need to build a platform where you build all of that in, so that this platform enables the teams to do DevOps. So with that, we are at the end. As you could see, the platform engineering is one of the key things you need to introduce in order to enable the teams to do DevOps. And this is the way how you can architect for continuous delivery. And as I always say, we are clearly entering the age of industrialized software development. Thank you very much.